Yes, sir. We are live on YouTube as well as on Zoom. I'll admit one student for us. Yes, sir. We can start. So you can introduce yourself and then you can begin, sir.
Okay. Hello, everyone. Welcome to this live session of the NPTEL course Transportation Network Analysis. I'm Hemant Gehlot. I'm the instructor of this course. I'm a faculty member in the Department of Civil Engineering at IIT-Kanpur. So, the objective of this live session is that if you have any queries, then you can ask them and I'll reply to those. We had already circulated one Google response sheet. So, if there are already some questions there, so we'll go through them. In case if you are not able to connect to this Zoom session, we also have a live YouTube channel where you can also put your comments and we'll reply there also. Okay. So, with this, let us get started. Let me maybe just quickly introduce about this course. So, this course is about um, learning some basic concepts related to network analysis with application to transportation. So, in the beginning, we will be targeting to cover basic principles of optimization. We'll be covering important optimization formulations. So, 2 weeks have already passed into the course. So, a lot of optimization formulations have been introduced by now, and after that we'll be moving into the analysis of algorithms, that is how to characterize that a particular algorithm is efficient as compared to another algorithm and so on. After that, we'll be moving to the analysis of various traffic assignment problems. So traffic assignment problems are required wherever we have to figure out that how do people distribute across various paths and routes when they have an option of going between several routes when they are going from one place to another and so on. So with this we can get starting to um, the various questions that have been posed here. So I'll first go through this some questions that have been put in the Google response sheet. um, One question that has been put by Amit Etrulia. So the question is transportation network analysis scope for civil engineering. So if I understand correctly, the question is asking what is the scope of this course as compared to civil engineering. So the objective of this course is to help you understand how can you apply optimization wherever such problems arise in transportation networks and in general anywhere, I mean. So for example, suppose if there is a warehouse, and from that warehouse some goods have to be delivered at multiple places in the city, and suppose there are limited number of trucks that are available to uh, this warehouse. So this warehouse will have to decide that in which order, suppose these different trucks should go to different houses, and which houses should be allocated to which trucks and so on, so that suppose the total time that is traveled by these different trucks is supposed minimized, and that will automatically minimize the total fuel that will be used by these different trucks. So there can be problems such as these where there is some particular goal that has to be reached, but there can be several constraints. For example, here in this problem, the constraints can be the number of trucks that are suppose available. Each truck can have a limited capacity of goods that it can carry and so on. So under such situations where there are some restrictions, constraints and so on, and when you have to reach a particular objective, so what decisions should a particular person make in order to achieve the best objective? Okay, so uh, that is the target of this course. So by the end of this course, you will be able to um, appreciate optimization. You'll be able to mathematically formulate various physical problems into optimization formulations. You will be able to think of what kind of algorithms to maybe use while solving them. And we'll be focusing a lot on traffic assignment problems also. Those are also very important, because suppose uh, a city planner has to make a particular decision that we want to add some particular roads with the objective of suppose minimizing the congestion in the city. Now the question is that there is limited budget that you can suppose add one road or two road and so on, and within this you have to achieve the objective of suppose minimizing the congestion. Now there might be a lot of options that would be available, that you can maybe connect one road from A to B, or one road you can connect from C to D. So now the question is, which two points maybe you should connect with a new road, so that the overall system travel time is minimized. So in order to answer that kind of question, we should be able to first fundamentally understand that what travel behavior uh, the different travelers that are there on this network behave and so on. So for example, if the travelers are behaving selfishly, that is they are trying to choose a route that minimize their own travel time, so in that situation, if our objective is that while constructing the new road we want to minimize the minimum uh, total system travel time, so what decision will be able to do so, that is at where uh, the construction of which new road will be able to achieve that process. And we'll be seeing as the course will progress that not necessarily every time maybe constructing a new road can result into reduction in the total system travel time. It may be other way around also. Okay, so in making these kind of decisions, wherever you have limited resources constraints and you have to achieve some particular objective, so there you need to have fundamental understanding of optimization, how to um, mathematically represent these different optimization formulations and how to solve them and so on. Okay, so I hope I have answered this question. And then there is another question, that is, give me an idea to find the reason why less people are using metro feeder services. Okay, now this question is slightly, it may not be directly related to this course, in the sense that first of all I don't know which context or which specific place this is being talked about. I mean, if there is a particular place, for example in India, where this kind of situation is being faced, but let us assume that suppose this is actually a case from a particular city. So then in order to answer this question, we need to be able to understand that what kind of different behavior, uh, like what are different options that are available to people while maybe going to metro, uh, in comparison to just choosing these metro feeder services. I mean, there might be some other ways also. Maybe people can use their own private um, resources. For example, they may book a cab and so on. They may not necessarily use this metro feeder services that is provided by the government. So we need to have full understanding of what all choice options are available to these different users, and depending upon what is the different attractiveness of these different options, we'll be able to answer that why a particular option, for example in this case the metro feeder services, are maybe gaining more utility with time, or they are maybe becoming less attractive with time and so on. So it requires that kind of data to answer this question here. So since a lot of specifics are not mentioned regarding this part, so we'll not be able to answer much here. But what I can say is that in this course we'll be covering some aspects related to discrete choice theory, where you have to understand that how do people make decisions when you have a finite set of choices. So there, this discussion of utility theory and so on is there. So we'll be going over through that. So once maybe we go through that, and we have also the access to different data to kind of understand this kind of question, hopefully it should be possible to understand that why maybe different metro feeder services are becoming less attractive in a particular area. Okay, so these were the questions that were available through the Google response sheet. um, Now, in case there are other questions from the participants, feel free to ask them. So you can unmute
Thank you so much,
yourself.
sir. Yeah, thank you, sir, for answering those questions posted via Google response sheet. Two students are joined directly on Zoom, sir, Mr. Faraz and Miss Sandhya. Faraz, do you have any doubts? Miss Sandhya, can you unmute yourself and ask the questions? Meantime, I will track the YouTube chat, sir.
Okay, okay. So, one suggestion that I have is, even if you are not maybe comfortable in asking question at this point, feel free to put any queries that you have in the discussion forum as this course progresses. So it has been only 2 weeks, and this course is of 8 weeks. So maybe when you will progress further, you will have more questions than what you have currently. So the reason I decided to have yeah, an initial live session is to get people started that I mean they have a lot of option of asking questions even if they are very trivial at this point. I mean you are free to ask them and so on. Okay, so I'll highly encourage that you use the discussion forum that is available with this course. It's a Google discussion forum, so that is available when you will be logging through your credentials on this NPTEL website.
So one question was posted on YouTube chat. I just copy pasted here.
Okay, sir, kindly provide me the constraints that I have to look into while trying to evaluate the reason behind less usage of metro feeder service. Chennai, we are going to take a survey. Again, see, there are three aspects to this question here. First of all, the question is whether is this an optimization problem? For example, if I understand correctly, we want to this question wants to evaluate the reason behind less usage of metro feeder service. Okay, so as such, it looks like we want to understand some particular aspects of this travel behavior. So that can actually be understood if we kind of design a survey which is able to ask people different kind of options that what are their preferences towards metro feeder services as compared to other services that are available and so on. So my thinking is that this the answer to this kind of question requires preparing a detailed survey that is able to evaluate these different options and is able to understand the travel behavior, and then after that it will require to do some econometric analysis where a particular model can be proposed to estimate the choices of uh, the travelers when they have to go to these different metro services. So as such, at this point, it does not looks like a optimization problem as such. Okay, so that is the thing. So since this course specifically will be targeting towards the formulation of optimization problem, so uh, this question will not maybe directly fit into it. So I cannot say at this point that there are specific constraints that need to be looked into. However, I mean, constraints can be understood in a different setting, that maybe when you are creating the survey, then you need to be able to understand that when you're asking the answers to different participants, not every participant might be having access to all kind of facilities. For example, uh, some kind of um, residents, depending upon where they're staying, they may be having access to metro feeder services, whereas others may not be having. Uh, Other situation can be some residents might be able to access some private facilities like cabs and so on, which maybe other people may not be able to access. So in that sense, there might be some constraints uh, that might be imposed on different people, that what are the different options that are available to them. Okay. Okay, so again in this part there is some question here: how to optimize the routes and frequency of service available. Okay, yeah, now this looks like some kind of optimization problem. So this one then requires first formulating this physical problem into the mathematical problem. So then it requires that you need to be able to understand that what are the different possibilities of different routes that are available. You need to quantify that in the area that you're targeting. In this case it is Chennai. Then this frequency estimation, I mean, the problem of optimizing the frequency, that will itself will have a lot of constraints, right? That um, you cannot have too frequent services because that will require a lot of resources. You might have a limited number of buses and so on. But you don't want to have very less frequency also, because then it will not be very meaningful for these different users that are there, because then they'll maybe prefer to shift to some other services that are available. Okay, so this problem of route optimization, frequency optimization, this is a very detailed complex problem. So there will be a lot of physical constraints that need to be modeled. Okay, and that might depend upon what is the specific context that we are looking at. Okay, so it requires modeling down all of those, first listing out all of those constraints that are physically there, and then trying to mathematically model it. Also trying to think that specifically when we are saying optimizing the routes and frequency, what is actually the goal that we are running after. Are we trying to suppose minimize the uh, total time that will be traveled by all the users in this network, or are we trying to maximize the profit of the agency that is trying to build this? So all of those questions should also need to be answered before we can actually decide how to mathematically model them. Okay, so these are a few things that need to figure out, and how to properly find the service that will be suitable for people the most. Again, that requires doing some kind of survey and asking them that what are their different um, preferences and so on, like what do they maybe value more. Do they value um, suppose uh, money over um, suppose uh, the distance that they can walk and so on. For example, if they are ready to walk a little bit distance, even if the metro feeder service is slightly away, then they will be maybe prioritizing the metro feeder service. Whereas if they value maybe um, the time more and so on, so they may want to use a private service and so on. Okay, so it the second answer the answer to the second question requires preparing a survey to find out that. Okay. Okay, so any other question that anyone would like to ask?
So two students joined, but right now they got disconnected. Um, I'm also tracking the YouTube. Right now, no other questions are posted. We will wait for 2, 3 minutes and then see sir, how it is going.
Okay, okay. Yeah, so we'll wait for
Sure,
a
sir.
couple of minutes. So if anyone has any questions, so either you can put it on the YouTube channel, or you can join this Zoom link. Okay, there is one question: as a mechanical engineer, what courses should I take which will help me in logistics and supply chain? How to join these courses? Mm, I mean, at this point, I mean, in NPTEL, I mean, I think this course will give you kind of the foundation for understanding optimization. But there might be other things also which may require to be understood. For example, some things which are specifically um, related to the context of logistics and supply chain. So that you will have to search if there are any NPTEL courses that can actually help you to understand the descriptive part of this logistics and supply chain. Okay, I mean, in order to first understand physically, I mean, what are the actual restrictions and so on, because this course will be focusing more on, once you understand the problem physically well, then how to mathematically model it. But depending upon what context you're focusing on, whether you are trying to focus on optimizing the transit services, or you want to optimize logistics, or you want to optimize the travel of private uh, uh, agencies and so on. So these different contexts can have different kind of um, objectives and constraints. So in order to mathematically model them, first we need to know or understand physically that what might be the issue. So maybe some courses which are specifically focusing on understanding of supply chain and so on might be useful. um, so you can actually check those. This course will at least provide you the understanding of optimization as such, and how you can mathematically model any optimization problem.
Thank you, sir, for answering that query. Let me just check once again on the YouTube whether any question is posted over there. No, sir, no questions posted so far. Maybe we'll wait for 2 more minutes. Miss Jyoti has joined on the Zoom directly. Jyoti, can you unmute yourself and ask the query? Or else you can post directly on Zoom chat as well. So whatever is comfortable, you can. Miss Jyoti, do you have any doubts? So we will give her a minute, sir.
Mhm.
So anything would you like to discuss in general, sir, related to the subject?
um, so what I'll suggest is that since these video lectures are anyway getting uploaded weekly, so keep going through them. And specifically, since the initial lectures are focusing on optimization formulation, so you should practice a lot in modeling these optimization problems. Okay, because these might be slightly new to many of the people, because usually there are not these kind of topics covered that frequently. So I'll suggest that whatever examples are covered in the class, that we should go through. But you can also you should definitely attempt whatever assignments that we have and so on. Okay, so that will give you some idea of what might actually come in the final exam. Okay. And in optimization problems, I mean, you need to understand things very closely, in the sense that you need to carefully see whether in a constraint, for example, is the following is a particular constraint applicable for a particular set of variables, or um, when you're writing a constraint, then if there is a summation involved, then what is the index for which the summation is going, and so on. So uh, some of these things will be slightly mathematical, so pay close attention to these things, because just a small change can make an optimization formulation incorrect. Okay, so that is the thing.
On YouTube, one student said that he is having some doubts, sir. We will give him a minute to post.
Okay.
Um, yeah. And then here, Ms. Jyoti, do you have any doubts? Please feel free to utilize this session. Kindly ask your doubts without any hesitation. You can unmute yourself and ask directly also. So Ms. Jyoti is not having any doubts, sir. So we will wait for a minute. If there are no queries, then we can wind up the session, sir. I'll just track the YouTube chat and then I will inform you, sir.
So in this first 2 weeks, we have covered a lot of important optimization formulations like shortest path, sensor problems. Then we also discussed some fundamentals of linear programming, and then we again covered some more optimization problems like knapsack, maximum coverage, traveling salesman, and so on. So all of these are very important formulations. Um, I mean, although these are mathematical formulations, but you will realize that a lot of these formulations are applicable in more than one applications. Okay, for example, in traveling salesman problem, although it seems more related to if you are visiting a set of places, but actually this problem also arises when chips are getting built and so on. So this kind of problem is also studied by electrical engineers, for example. Okay, knapsack problem, since it's related to fitting the best set of items when you have some space restriction and so on, and with the objective of maximizing their total value. So that is a very old problem, because it arises, for example, in military applications. If there is a backpack, you have to give it to a soldier, so you don't want to make it very heavy. So then what are the most important items you should place when you have some restriction on, suppose, the number of items you can keep, or the total weight that you can have. Okay, so uh, even in applications like that, these optimization formulations are applicable. Okay.
So no questions are posted. And then the participant who just joined on Zoom also left. So can we end the session now, sir?
Yes.
Yeah. Thank you so much, sir, for your valuable time. Sir, in future, would you like to conduct one more session, sir? Maybe after sixth or eighth week?
Yes, yes, possibly, yes.
Sure, sir. Sure, sir. So we will announce the date later on, sir, on the portal. Uh, Once again, thank you very much, sir. Thank you, participants. We are going to close the session now. See you,
Yeah,
sir.
thank you everyone. Thank you.